So here we go. So you see there's a radical, you see an a squared minus an x squared. So this is going to cue you in. This is when you want to do trig substitution. So since it's the square root, oops, where did my pen go? Since it's the square root of a squared minus x squared, you want to use the substitution x equal a sine theta. So I'm just going to put it right below. X is equal to, so a would be 4, because 4 squared is 16. 4 sine theta. So be really careful. So it's x equal here and theta here, and the number is here. So it's very odd. You're not used to doing this. Okay, the most common mistake is to forget to find the dx. So do it right away. Okay, so the dx is going to be 4 cosine theta d theta. So remember, this small integral is going to get huge when you substitute in the thetas. So inside the radical here, I'll have 16 minus, and for x, I'm putting this in, so I'm going to do the squaring. So I have 16 sine squared theta. Dx gets replaced with 4 cosine theta d theta. And on the denominator, I have x squared, so that's 16 sine squared theta. Okay, so now the reason you do this, remember, is to get rid of the radical. So let's spend some time in here so I can factor out as root 16. So I'm just going to go slow so you see exactly what I'm doing. And then this 4 cosine theta, and then this 16 sine squared. Okay, so this is a 4, and this is a 4, and this is a 16, so all the numbers go away. So that's kind of nice. So let's talk about this. So this here, so I have the square root of 1 minus sine squared, so that's the square root of cosine squared. And I'm just going slow to make sure that you really see it. Okay, so now I want to take the square root of the cosine squared, so that gives me a cosine. So I have a cosine times a cosine, so that's cosine squared over sine squared d theta. So what does that give me? That gives me cotangent squared of theta. Do I know what that is? I don't. What am I supposed to do now? So this is a correct, from here to here is correct, but it's not helpful, is it? So I'm just going to put an x through that, and I'm going to think, is there something I can do with this cosine squared? I know an identity. That's 1 minus sine squared. So 1 minus sine squared theta, and then sine squared theta down here. So then I have subtraction in the numerator of the fraction. So this is 1 over sine squared minus 1, correct? So what is this? This is cosecant squared. Whoops. Cosecant squared theta minus 1. Do I know the antiderivative of cosecant squared? I do. The derivative of cotangent is negative cosecant squared. So this gives me a negative cotangent theta. Taking the antiderivative of this gives me minus theta. Remember, when you're taking the antiderivative of 1 in theta land, right, you get a theta plus c. All right, so now I need to get back to x's. How do we get back to x's? It's all about the triangle from the first substitution. So this is my first substitution. So I'm going to rewrite it as x over 4 is sine theta. Draw the triangle. Oh, trying to draw theta. Okay, there's theta. So opposite over hypotenuse. I need the other side here. So I'm going to use Pythagorean theorem, right? 16 minus x squared, and this always should be an expression that was in your first integral. Look at that, little happy moment. Okay, so now I need to find cotangent. So cotangent of theta, right? Cotangent of theta will be adjacent over opposite. So adjacent over opposite minus theta. So the only time we do the inverse trig function is when we have theta in here. So I'm going to take the inverse sine of both sides of this to get the inverse sine of x over 4 plus c. So we should have only x's in our answer.